Hey guys, today we're going to learn about how to create our own classes. I'm going to try to keep this as short as I can, but there is a lot of information that needs to go into this, so I apologize. I'm going to keep it short. We've been using classes for a very long time. Here's some examples. The scanner class, the file class, the print writer. What you see there is another way that you can actually declare a string. You see strings declared like this in Runestone. We use a shorthand way of declaring strings. We can leave out some of these pieces. We just do, string str equals hello world. The reason why that exists, that short form way that we use exists, is because we make strings so much. Java has a built-in shorthand way to do it. But this is how it would normally look. And if you notice between all four of these, they look very similar. How we create these objects, right? And so we talked about that quite a bit in the past. There is a scanner class, and the scanner class is kind of like a blueprint. It sets up for us how to create a scanner, but by itself it doesn't have any kind of value by itself. It doesn't hold value until we actually create a scanner like this with that line of code. Same thing with file. There's a file class that has everything in it that we need to create a file object, but it doesn't create one until we do this line of code and it creates that file object. So a class in Java defines a blueprint for creating objects. When creating objects, you create new instances of the class. So those are just some vocabulary words you need to be familiar with. Is that when we create these objects, we're making instances. If you want to think about that as like a copy, it's not really a copy. It's more like we're making a version of that class. I would rather use that word. Okay, so here's kind of an allegory or a metaphor for how this kind of works. This is called the OOP dog. So the word OOP comes from Java is an object-oriented programming language, and there's several OOP languages out there. What that means is that they use object-oriented programming. They use objects to get a lot of things done. And so for us, let's take a look at this dog. So the base class in this case would be like the string class or the scanner class. By itself, it doesn't have value. It's got a bunch of properties and attributes, and it's got some things that it can do, but it doesn't do anything until we create an object of it that has value and we can use. And so in our scanner, whenever we do this line of code and we give it system.in, that tells it where to scan from, the keyboard, right, or input. That's us giving it value. Until we do that, it doesn't have any value. It just has, hey, here's what a scanner looks like. And then once we do this, we're giving it value, and it becomes a scanner object that we can use. Okay, so back to this metaphor of the OOP dog. Once we create the object or the instance of the dog, it now has value. Its color is yellow, its eye color is brown, all this good stuff. But then it still gets everything that a dog can do. It can sit, lay down, shake. So just like the scanner, once we create it, we give it some value with system.in. It can still do everything that a scanner can do. It can scan whatever it is we're needing to scan. So the main takeaway here is this. A base class, like scanner, or like file, print writer, all those, and there's plenty of others we haven't looked at. They're empty. They're just a blueprint. Think of houses. When you have blueprints of houses, the blueprint is not the house, right? The blueprint is how you make the house. Based off that blueprint, you can make as many houses as you want. And when you make those houses, you ask the homeowner, hey, what color do you want? What type of brick do you want? What type of roof do you want? Whatever, right? And so as you take the blueprint and you specialize it, whenever you make that instance of it, that object, you specialize it for that person or that application. Same thing with the dog. This is a yellow dog. It's brown. It's blah, blah, blah. So when we make these objects, we're giving them some value here. We're saying, hey, this is where you scan from. This is where you look for the file. This is what I want the value of my string to be. And so whenever we create them, we're giving them these values. Okay, very important concept. Okay, now back to it. So we've been using these objects, these classes, since a long time. But we haven't made our own. We've only been using the ones that are built into Java. And so let's take a look at how we can make our own objects. And I'm going to pop into Eclipse here so you can see this in Eclipse. What we're looking at is what's called the rectangle class. The rectangle class creates a rectangle. If you notice by looking at the code, just glancing at it, there's no value here, right? There's nothing except for these zeros down here. There's not a whole lot going on. So let's break it down. The first thing you'll notice is there's no main method. There's no public static void main. That's because these classes like this are simply a blueprint. They don't do things on their own. They don't run on their own. The main method, whenever we have a main method, we'll look over here, the main method indicates this is where we're going to run our code from. The main method is usually what really controls what's happening, right? These don't do that. These classes that we're going to build, these are, like I said, blueprints. They're meant to be like skeletons. They don't really do anything on their own. They're just there to set up or to create something else, right? Or to create those things. And so where we start with our class header, public class rectangle, which is normal. The next thing is what is called, these are our attributes. So if you think of the dog had an eye color, it had a height, it had a weight, it had a name, right? So any attributes that your class should have will go at the top. And they are created using these variables. You'll notice that these variables are private. This is important. We'll talk about this a little bit later on why these are private. Pretty much it makes it to where these variables are only usable within this one class. It's to prevent outside manipulation on these variables. So these variables, length and width, are only accessible from within this class here. Nothing outside can edit them or anything like that. But why do we have length and width? Those are the attributes of a rectangle. That's why we have length and width. So any attributes or properties that a class would have, or that blueprint would have, that object would have, that's what needs to go at the top. These are called instance variables because they are set up whenever we make an instance of the class. So you'll notice they don't have value right now. They're going to have value whenever we create a rectangle later. Keep in mind, keep it straight in your head, this is not a rectangle. This is a blueprint for creating a rectangle later. The reason it's not a rectangle right now, it doesn't have value, as you can see. Okay, so we've got length, we've got width. These could be set to nothing here, or they could be set to some default value. Just know we can do that. These just don't have a default value. We're going to let the user set those values when they make the object. And when I mean make the object, here's what I'm talking about. This is us making an object. And we'll look at later how we can make an object like that with the rectangle class. Okay, so like I said, you'll notice these don't have values right now, right? Here's how we give them values. The first set of methods that we're going to have inside this class, and that's why we learn methods first before we learn classes, are called constructors. Constructors are meant to, and we have two here, we'll just look at this one. Constructors are meant to set up your class, meaning, or set up your object. They either run setup operations or they simply give value to the instance variables up here. By the way, instance variables can also be called fields. Okay, so you might hear those two words interchangeably here and there in the book or online. So here our constructor is simply setting up our variables, our instance variables with values. You'll notice they're taking in two doubles. This one's taking in two doubles. And what's happening inside the body of this method is it's simply passing off that value off to the instance variables. Here's why that's important. Remember I said these are private. That means they can't be accessed from outside. So if we want to set up the values for length and width, we have to have a way to do it. We can't just say length equals 5 from somewhere because they can't be accessed. We can do it through a method. So we call this method here, we send it to doubles, and then in turn, because this method exists in this class, it in turn has access to length and width, and so it passes off those values to them. When it does this, length and width are accessible all through this class. So now everything else in this class, everything, now has access to length and width with values now. So if I send 5 and 10, now length and width is 5 and 10, and everything in here will use the numbers 5 and 10. Okay, next we have a no-arg constructor. So what a no-arg constructor is one that doesn't take anything in. So if the user were not to know like what length and width should be, it has some default values that it can set them up with so that it doesn't error out. It doesn't give us a problem, right? Say, hey, if they just accidentally or if they intentionally don't want to give us a number, we'll set in 0, 0. Default constructors typically set things to default values like 0, null, false, okay, so things like that. The next thing up, we have some other methods. These are called setters. And I'll tell you what, I'm going to get to these in another video. Okay, welcome back to part 2. Still going to try to make this as quick as possible. So where we left off was with constructors, right? We talked about how we set up these values. Well, what if we want to change those values later? Like I said, these variables up top aren't accessible from outside. So we always have to have a method to help us manipulate them or change their values. So here we have what are called setters. Setters are methods that take in values and allow us to edit or change or update or set values for our instance variables. So here you'll notice this looks just like the constructor, right? So these setters will always be void because they're not going to return anything. They'll take in a value and they'll simply pass that value off to the local or the instance variable. Okay, that's it. That's all they do. Typically, for every instance variable you have, you'll have a setter as well, so that it's just good form, so that people can always come back and change the values they want to. One more thing I want to take note of with constructors, you'll notice that it has no return type here. It has no return type, not even void. So you don't put void, you don't put, int, boolean, double, nothing. Nothing goes there. Also, you'll notice that the constructors have the name of the class. That's a rule. So you can always tell what a constructor is, or you can see them very easily because they always have the name of the class. That's what makes the constructor constructor. Okay, usually with setters we say set whatever, set length, set width. That's the typical format. Likewise, we have things called getters or accessors. These are made simply to get the values back. Remember, we can't access these instance variables, but we can access them through methods. And so calling this method, getLength, it returns a double because length is a double, and all it does is returns length. We want to do this for every instance variable we have. So every instance variable you have in a class will have a setter and it will have a getter. Notice that getter is pretty simple. It has a return type and a return statement. That's it. Setters and getters are pretty simple, so don't overcomplicate them. They're not meant to do any kind of calculations. We can also have extra methods inside of our class. So here I have a method called calcArea. All it does is calculates the area of the rectangle and returns it. These methods can be as elaborate as we want, or they can be as simple as this. Okay, now that we know what a class looks like, this is the skeleton, this is the blueprint, okay, and we'll learn more about all these little pieces later. Let's see how we actually use it. So coming over here, this is going to be new, the fact that we're going to be using multiple classes. So here we have our base class that we created. Here we have what do we call a demo class. It has a main method, so this is a class just like every other one we would ever write. And this one's going to utilize that class that we just created, the blueprint. You'll notice the first line is me creating a rectangle. Let's break this down, okay? You'll notice it looks a lot like scanner, input equals new scanner. file equals new file. It follows that same format. So this is us making a rectangle called box1, and we're sending it the values 10.0 and 20.0 through the. So here, let me write down exactly what's happening here. In Java, the right hand side is run first. So this is going to perform its action, and then it's going to do whatever this is. It's going to assign something to this variable called box1. Okay, let's talk about what happens though. The new keyword is super important. The new keyword is a command in Java that says, hey, I want to create a new instance of this class. I want to make a new object. In this case, a rectangle. So then it looks over here and says, oh, this is what I want to make. I want to make a rectangle. And then it looks in here and says, I want to give it these values. Just like scanner. When we say new scanner and we send it system.in, we're saying, hey, I want to make a new scanner. And I want to send it, I want to be able to use it for the keyboard, system.in. Okay, here's technically what's happening. You'll notice that this looks familiar. That's because that is simply a method call. What method is it calling? It's calling the constructor at the top, right here. How do we know? Because this constructor takes two doubles, and I'm sending it two doubles. So every time we've ever done something like this, like when we send system.in to scanner, it's actually calling a constructor inside the scanner class and sending it those values to set it up, to set up the object. Okay, so when it does that, it does a second job. It sends the values, it says, hey, make this object. It creates the object in memory. So it gets created, it gets put in memory somewhere. Nobody knows. If you recall back to maybe we've done some things in class that I've shown you, like how we keep tabs with a string of on our objects and stuff. So it's somewhere in memory, we just don't know where. So now we move to the left side. We have an assignment operator, an equal sign. What this is going to send back is the memory location of the object. It's going to say, hey, I made the object, I gave it 1020, here's where it is in memory. We have to store it somewhere or we lose it. And so the left-hand side is simply a variable. This is called a reference variable. This is the data type, just like we would put int, string, double, whatever. This is a rectangle, so we call it a rectangle. This is a variable name. We can call it whatever we want. We want to be descriptive. This variable, this is important, is called a reference variable. You're going to hear that a lot. The reason we call it something special is because it references an object. Okay, I want to be clear. Box1 is not an object. Box1 is simply a variable. It holds the memory location of where that object is in memory. That's super important. Okay, now I have another box created the same way, except I don't send it any values in the parentheses. What that's going to cause it to do, it's going to cause it to use this second constructor because, and it's going to know which one to use because it's going to look right there at the parameters. It's going to say, hey, they didn't send me anything, so I'm going to use that one instead. Okay, next, because I didn't give it anything, box2, any value, remember, this set all the values to 0, 0. I need to come back later and give it some value. So what you see here is me using the setters that I had in the other class. Let me bring it up here side by side. Here's my two setters. Remember, they take in a double and then they pass off that value to the local variables. Okay, so I'm going to send it a 20, which means it's going to pass off a 20 to the length, a 40 to the width. Keep in mind, these are two totally separate instances. Two totally separate rectangles. This is like taking a blueprint of a house and making two separate houses. I've got box1, box2. Okay, let's see what I can do now. See if I can make this bigger. Maybe. There we go. Simply going to print them out. So what you'll see here is I'm going to call get length. That is a getter. Remember, all the getters did was send back the values. And so when I call box1.getter, or sorry, get length, all it's going to do is return length. And because it's in a print statement, it'll print it out. Now I can use these values in calculations any way that I want to. It's sending back a double. So I can use these in any place that I would normally use a double, just like any other method. Okay, we're using this just like any other method. Here's the only thing that's a little bit different. The box 2 dot, the box 1 dot, that dot, right? We've used this before with scanner when we say input dot or scanner dot, KB dot, whatever it is you use. File input, we say file dot or input file dot. So the first part is us saying this is the object, this is the reference variable that I want to use. I want to use box 1. Use box 1, call its getLength method. Down here I say, okay, I want to look at box 2 now, call its dot getLength, its getLength method. That's how we denote which object we want to deal with, or which instance of the class we want to deal with. That's very important. And then we're doing calculate area, which will calculate the area. So if I hit play here, it does all this kind of instantly, but it does go in order. If I were to move this down below, obviously, it would cause some problems. And it automatically tells me, hey, that's an issue because I've already declared it, duh. But all this breaks because it's saying, hey, that doesn't exist. So I do need to put these up top. I have to create these objects first before I use them. So let's recap. Really important things to remember is that when we create these objects, think about the dog. If you don't want to think about the dog, think about the houses. The houses are a really good metaphor as well, and I like that. The base class is simply a blueprint. There's no value to it. It simply has all the attributes that the thing should have, and then it has ways to set up those things with values, ways to get those things or to see them, and then it may do some other things like the dog can sit, the dog can beg, whatever, run. This can calculate area, so it can have some other things that it can do, but it can't do these things without values. That's why we create the objects, we send it value so that it can become an instance, it can become an actual house. And what's really great about object-oriented programming, or OOP, is the fact that I can make as many rectangles as I want. Okay, so a lot of y'all like to know the why. That's the why. Once I create this rectangle class, this big long class, and think, we can make these way bigger. Rectangle is just an example. I can come back and all I have to do to make a new rectangle is one line of code. A simple blueprint to create as many of those things as I want to make. And I never have to edit anything in here. This code's done. I don't have to look at it anymore. All I got to know is how to set it up and then how to use it for whatever I want to use it for.